So in this video, I'm going to show you how to calculate the specific heat capacity of an object like this aluminium block. So what you're going to need to do this is a power pack, the aluminium block. You're going to need some wires to join up the circuit, a stopwatch to record the time, a thermometer to measure the temperature in degrees Celsius. You're going to need a heater that you can connect up into the circuit that fits into the object like so. You're going to need a voltmeter to measure the voltage, an ammeter to measure the current, insulation to wrap around the aluminium block, and a mass balance to record the mass of the object. So for your results, in order to work out the energy that is transferred to the block, you'll need the equation energy equals current times voltage times time. And you want time to be in seconds, voltage to be in volts, current to be in amps, and energy in joules. The second equation we need to calculate the specific heat capacity is change in energy equals mass times specific heat capacity times by the change in temperature. So we want to calculate the specific heat capacity. So we can rearrange this equation to give us specific heat capacity equals change in energy divided by mass times change in temperature. So there are a few things we need to measure and record. So your table should look something like this. We need the mass of the aluminium block, and that will be in grams or kilograms. You want it to be in kilograms. We then need the potential difference, which is the voltage. And we measure that in volts. You want the current, which is measured in amps. You want the time, which is in seconds. The starting temperature, in degrees Celsius. The final temperature, in degrees Celsius, and the change in temperature, which is in degrees Celsius. So we need to measure and record quite a few values. So we're going to start by setting up the circuit. So this is our power pack, it's plugged into the wall. So we need two wires coming from the power pack, one in the positive terminal and one in the negative terminal. It doesn't really matter which way the colors go because these wires are all the same inside. They're just different colors. We then need to join our ammeter into the circuit, which is used to measure the current. Okay, I'm actually going to swap the color of the wires, and you'll see why in a second. So we need another one from this ammeter. And then we want to join the heater into the circuit as well. So this is our heater, and as you can see, it has two connections on the end that fit the wires. And then the heater goes into the aluminium block. We then need to put the thermometer into the aluminium block as well, so we can record the starting temperature and final temperature. And we want to put the aluminium block into the insulation. Alright, now the one component of the circuit we haven't connected yet is the voltmeter. And this is why I've left the red wires, because I want you to be able to see how the voltmeter has its own separate loop in the circuit. It's connected in parallel. So we need to connect this over the heater. So as you can see on the ends of these wires, you have these holes, so you can connect it in parallel. So one goes there into our voltmeter, and the second one goes here into the voltmeter. So the voltmeter is connected in parallel. All right. And then we need our stopwatch to record the time. So now we're going to record the mass of the aluminium block using a mass balance. Now this will give you the mass in grams. We want the mass in kilograms. So you can convert the grams to kilograms by dividing by 1,000, because there are 1,000 grams in 1 kilogram. So 944 divided by 1,000 will give you 0.944 kilograms. And we can write that into our table. 0.944 kilograms. So before we turn the circuit on and get started, remember to measure the starting temperature. As you can see from the thermometer, the starting temperature is 23 degrees Celsius. So we're going to record that in our table. Starting temperature is 23 degrees Celsius. Now we're going to get started. So you want your power pack to be set to 12 volts. If it isn't, you can change it to 12 volts. There you can see the 12. We're going to turn this on and we're going to start the stopwatch at the same time. Now it's important that you record the current and the voltage at the beginning. So right now the ammeter and the voltmeter are on 0. Let's get started. So there you can see the time is going. The heater should be getting warm. And we're going to take our current as 3.72 amps. And we'll take the voltage as 10.75. We're now going to leave this on for 10 minutes and record the final temperature. Okay, so it's been 10 minutes. We're going to record the final temperature, which is 30 5 degrees Celsius. We'll record that in our tables. Turn the circuit off. So the final temperature is 35 degrees Celsius. The time it was on for was 10 minutes. So if we convert that into seconds, 10 minutes times 60 seconds in 1 minute gives you a total of 600 seconds. And final column is the change in temperature. So if we started at 23 and we finish at 35, then the difference between these two is the change. So 35 take away 23 leaves you with 12 degrees Celsius. So the aluminium block's temperature increased by 12 degrees Celsius. So firstly, let's calculate the energy in joules transferred to the aluminium block. So we can use this equation: energy equals current times voltage times time. So the energy in joules equals, we're just going to replace the words with numbers. So the current was 3.72 amps multiplied by the voltage, which is 10.75 volts, multiplied by the time, which was 600 seconds. So the energy transferred to the block equals 3.72 multiplied by 10.75 multiplied by 600. And that gives us 23,994 joules. Finally, we're going to calculate the specific heat capacity, which is change in energy divided by mass times change in temperature. So this equals, once again, we're going to replace the words with numbers. The change in energy was 23,994 joules. Divided by the mass times the change in temperature. Now the mass was 0.944 kilograms. Multiplied by the change in temperature, which was 12 degrees Celsius. And this will actually give us our unit. So the specific heat capacity's unit is joules per kilogram and then degrees Celsius. So let's do the final calculation. 23,994 divided by, in brackets, 0.944 kilograms multiplied by 12 degrees Celsius. And the specific heat capacity is 2,118 joules per kilogram degrees Celsius.